So let's take a look at number 1. We define the distance between the points. So what's our distance formula? Perfect. So x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So here I have x1, y1, z1, x2, y2, z2. We can just plug all of those in. So this would be 1 minus 5 squared plus 4 minus negative 3 squared plus negative 3 minus 3 squared. So 1 minus 5 would be negative 4, and negative 4 squared is 16. This becomes a plus, so 4 plus 3 would be 7, and 7 squared is 49. And then negative 3 minus 3 would be negative 6. Negative 6 squared is 36. And then we just add all of these together. So what do we get for the distance? Square root of 101. Perfect. You can't break that down, but if you can simplify it, make sure you simplify it. You have to know the distance formula for the quiz tomorrow. All right, number 2 is the same thing again. It's just the distance formula, so I'm going to go to number 3. 3, we have to find the midpoint. So what's our midpoint formula? It doesn't matter. Since you're adding, it doesn't matter if it's y1 first or y2 first. But it's always important that you keep it consistent because it does matter with the distance formula when you subtract. So, all right, so I have x1, y1, z1, x2, y2, z2. So let's plug everything in. So this would be negative 7 plus negative 6 over 2. And then 9 plus 6 over 2. And 3 plus 6 over 2. So this is negative 13 over 2, 15 over 2, and 9 over 2. If the quiz says no decimals, you leave your answer as fractions like this. So make sure you know the midpoint formula for tomorrow. All right, I'm going to keep going down, so let's take a look at number 6. We define the center and radius of a sphere. So we know our equation of a sphere is similar to our equation of a circle. So it's x minus h squared plus y minus k squared plus z minus j squared is equal to r squared. So we want to get our equation here to be in standard form in order to find the center. So what should I do to do that? Awesome. I'm going to move the 19 over and then combine or put together my like terms. So I have x squared. So I'm not combining them. I'm just going to rewrite them together because my goal is to complete the square. So I'm going to do that down here. So I have x squared plus 4x, leave a space, and then I have y squared, no y with that, and then plus z squared minus 8z is equal to negative 19. Oh, I didn't leave a space there. Okay. So let's complete the square with the x's. What is the formula that I need to complete the square? B over 2 squared. And what's my b with the x's? 4. So it'll be 4 over 2 squared. 4 over 2 is 2. So I have 2 squared. So what's going to go into my parentheses? Thank you. Thank you. X plus 2 squared. And then what am I adding here that I also need to add on the other side? I'm adding 4 because it's 2 squared, so I have to also add 4 to the right side. What do I need to do with the y? Nothing. Just leave it as y squared. And then let's complete the square with z. So what's my b here? So negative 8 over 2 squared. So negative 8 over 2 is negative 4. So I have negative 4 squared. What's going to go into my parentheses? Z minus 4 squared. And then what am I adding on this side that I also need to add on the right side? I'm adding 16 because 4 squared is 16. So I also have to add 16 on the right. So on the right side, I end up with 1. So what's my center here? Perfect. Negative 2, 0, and 4. You always switch the signs. So negative 2. Y doesn't have anything with that, so that's why our y is 0 and positive 4. And then what is our radius? 1. Whatever it's equal to, we want to take the square root of that. So the square root of 1 is just 1. So for 4, we have to find the standard form of the equation of the sphere with the given characteristics. So again, I'll write my standard form. I have x minus h squared plus y minus k squared plus z minus j squared is equal to r squared. So what do I do? Just plug in the h, k, and j, and the r. So I have x minus 4 plus y plus 9, because we'll change the sign, squared. Thank you. Plus z minus 5 squared is equal to what? 81. We just square our radius. And that's our answer, so we just plug it in there. So what's the difference between 4 and 5? Number 5 gives you the diameter. So if our diameter is 10, what does that mean that our radius is? 5. So when working out the review, Ms. Meadows thought the diameter, or the radius was 10. But no big deal, because we know that the radius is 5 if the diameter is 10. So we just plug everything in. So I have x plus 5 squared plus y minus 9 squared plus z minus 6 squared. And that's equal to what? 25. So just be careful with the wording. Don't work too fast where you don't read. So let's take a look at number 8. We have an initial point and a terminal point, and we have to write the component form of the vector. And we have to find the magnitude and the unit vector. So how do I find the component form? Terminal minus initial. So here I would have 0, 5, 9 minus 0, negative 9, 9. So 0 minus 0 is still 0. What does my component form of a vector have to have? Does it have the parentheses? It has the arrow brackets. So 0 minus 0 is 0. 5 minus negative 9 would be 14. And then 9 minus 9 is 0. So So that's our component form. How do I find the magnitude of V? Perfect. Just take the square root of everything in component form squared. So it'll be 0 squared plus 14 squared plus 0 squared. So I have the square root of 14 squared. It kind of doesn't matter what 14 squared is because I take the square root of it anyway. So what's my magnitude? 14. Magnitude's just positive. Any questions? All right, C, we have to find a unit vector in the direction of V. So how do I find the unit vector? So I take the component form, which is 0, 14, and 0, and divide it by the magnitude. So 0 divided by 14 is just 0. 14 divided by 14 is 1. And 0 divided by 14 is 0. So this is our unit vector. So it's the vector divided by the magnitude. That is a unit vector. So 9, we just want to plug our vectors in to the equation that it gives us and then solve. So I have 3 times vector W, which is the one all the way to the right, so 0, 10, negative 10, minus 2 times vector V, so 3, negative 2, negative 1, plus vector U. So I would say these types of questions are where most mistakes happen because it's just a lot of little math, so be careful with your signs. So I'm going to distribute the 3. So I have 0, 30, negative 30. Here I'm going to distribute the negative 2 and then change it to a plus. So this would be negative 6, positive 4, and positive 2. And then the last one is the same. You can either add 2 vectors together and then add the third one or just add all 3 together. So I'm going to add all 3 together at once. So 0 plus negative 6 plus negative 4 would be negative 10. 30 plus 4 is 38. Negative 30 plus 2 would be negative 26. So that's our vector Z. For 13, we have to find the dot product. How do I find the dot product? So multiply the x times the x. So the first one, so 2 times 8 would be 16, plus the second one times the second one. What's 8 times negative 7? Negative 56, plus the third times the third, which is 16. So what is 16 minus 56 plus 16? 24? Negative 24. So the dot product will always be just a number. All right, let's take a look at 15. So this one's the same thing. We are finding the dot product. It's just written a little differently. But we can change it to be in component form if we like that better. So it'll be 7, 8, and negative 4. And then 4, negative 1, and 5. So when you write it in component form, you just get rid of the I, J, and K, and you just take the coefficients of each. What if we didn't have like a K at all? What would our Z be? 0. Perfect. So dot product, we take the first ones, multiply them together. So 7 times 4, 28. 8 times 1, negative 1, would be negative 8. Negative 4 times 5, negative 20. And we add them all up together. So what do we get? 0. What do we know about something that has the dot product of 0? It's orthogonal. This one's not asking if it's orthogonal, but we know it is.
Are there going to be parallels on the test too?
So for 17, determine whether u and v are orthogonal, parallel, or neither. So if we want to, we can rewrite it in component form. So I have 6, -9, 3, -1, -1, and -1. So orthogonal, I have to take the dot product, and it has to be equal to 0. So let's do the dot product. First times the first, second times the second, plus the third times the third. So what's -6 plus 9 minus 3? 0. So is this orthogonal? Yeah. But if it wasn't orthogonal and we were checking to see if it was perpendicular, I would say 6 over -1. Parallel. So 6 over -1 would have to be equal to -9 over -1, which has to be equal to 3 over -1. These are not equal, so it is not parallel. Which obviously, if it's orthogonal, it can't also be parallel. So for 11, we have to find the magnitude of v. How do I find the magnitude? So we take the square root of the first number squared plus the second number squared plus the third number squared. So this will be 64 plus 9 plus 36. So the square root of 109. Can we simplify that? Nope. Remember, if you can simplify it, simplify it. If not, just leave it. Any questions here?